By the end of this lesson, you should be able to graph sine x and cos x with vertical and horizontal stretches and compressions, reflections, and vertical and horizontal shifts. So we're taking all of the transformations that we have been working with throughout the entire semester, and we're going to apply it to the graphs of sine x and cos x. Before we start transforming sine x and cos x, let's just do a quick refresher of what these graphs would look like. So we're asked to graph 2 cycles of sine x and then 2 cycles of cos x. So the first thing I'm going to do is I'm going to add in a scale. If we're doing 2 cycles of both sine x and cos x, we know one period is 360. So if we are going to do 2 cycles, we need to make sure we get to 720. So I'm going to skip every 4 boxes and call that 90 degrees. So we'll have 90, 180, 270, 360, and so on. So now we have a scale on the x-axis. Let's add a scale on the y-axis. So I know that the maximum value of sine and cos is 1. So I can really put 1 unit anywhere I want. I might as well just use up the whole entire graph. So maybe I'm going to make 6 squares as 1 unit. And if I do that, that's what my scale will look like on my x-axis. Or sorry, my y-axis. I'm also just going to make sure that this is clear, that this is where the y-axis is. Oh, that wasn't good. Let me try that again. Okay. So now we're ready to graph. So starting with the graph of y equals cos x. Sorry, let's start with sine x, the one on the top. So I know the sine of 0 is 0. So I know that this graph starts at 0, which means it also must end at 0, 360. Then we know it's going to curve up, come down, and back again. So in the middle, it's going to hit 0 again at 180. And then we know it's going to come up and down again. So in the middle of 0 and 180, which is 90, it's going to reach its maximum value of 1. And it's going to reach its minimum value between 180 and 360. It's going to come down here. And so we're going to put a -1 at 270. So now that we've got one cycle, we'll connect it. Let's do a second cycle. So again, this is going to repeat like this. So if we fill in the points, it will look like so. So again, everything is symmetrical. So if it starts at the period starts at, sorry, the cycle starts at 0, it's going to end at 0. In the middle, it's going to hit 0 again. In between, in the first quarter here, it's going to hit its maximum value and then its minimum value. And now we can just connect them. And now we've got 2 cycles of sine. So now let's do the exact same thing for cos. So the cos of 0 is not 0, it's 1. So we're going to put a dot at 0 and 1. And we know that if cos starts at 1, it's going to come down and end back at 1. Sorry, here we are at 360. So I know that at 360, the y value, or the value of cos, will also be 1. Then we know cos is going to look like the bowl. It's going to come down, come back again. So it's going to reach its minimum value between 0 and 360. So that's going to be 180. And it's going to hit the x-axis as it travels between 0 and 180. So right in the middle of that is 90, and again at 270. So now that we've got one cycle, let's do a second. So try adding the second cycle on your own. So here are our points for our second cycle, starting at 360, ending at 720 now. The middle of 360 and 720 is 540, and then the middle of 360 and 540 is 450, and then it's going to come back and hit at 630. So now we can connect them. So here are our graphs of 2 cycles of sine and 2 cycles of cos. Now that we know the basics of how to graph these parent functions, we're going to apply all the same transformations that we did in our first unit and throughout the semester. So we're going to take a look at what A is going to do, what K is going to do, D and C. Same with to the cos graph. Let's do a quick refresher of how to recognize different transformations on our parent graphs. So if we define C as a constant that's being added or subtracted outside the function, and if we define D as a constant that's being added or subtracted inside the function, so directly to x, let's review what each of these things will do. So if C, this letter out here, is greater than 0, the graph is going to be translated up by C units. And if C is negative, it's less than 0, it's going to be translated down. when we're working with periodic functions, specifically sinusoidal functions, instead of calling, or another way to call a vertical translation is a vertical displacement. So you might see this word or this term instead. It means a vertical translation. Now taking a look at d, this constant that's being added or subtracted inside the function. If d is greater than 0, the function will be shifted to the right. However, it will look like this. So our d value in this case is 3. It's not negative 3 because look, the negative is already there. So d is defined as whatever is beside the negative. So our d value is 3. So in this case, the graph would be shifted to the right. And if d is less than 0, it would look like this. There would be a little plus sign in front of it because this is equivalent to saying x minus negative 3. And so our d value is negative 3, therefore it's less than 0, and the graph is going to go to the left. We've been calling this shift a horizontal shift. Another way, or another term that's used when we're working with sinusoidal functions, is a phase shift. So vertical displacement is another way to say vertical shift, and a phase shift is another way to say the horizontal shift. So make sure that you can recognize both of these words or terms. So we're going to start off with some baby transformations. So we've added a c value. We know here our c value is 1, so we're going to be shifting up 1. And here our c value is negative 2, so we're going to be shifting down 2. Before we start to graph these transform graphs, let's first graph our original parent function because it asks us to do it. So we're going to graph 2 cycles of sine x. We did this on the previous page, so this would be pretty simple for us. Just let's think ahead. We're going to be graphing sine x, and then we're going to be shifting it up, and we're going to be shifting it down. So our x values are not going to be affected, but our y values are going to be affected. So because our x values are going to be affected, I'm going to use the same scale that I used in the previous page. So I'm going to skip 4 squares and put 90. You might have your own way to do it, and that's fine. But in terms of the scale on the y-axis, I know that here I'm shifting up 1. So our maximum value is going to go from 1 to 2 now because we're shifting that 1 value up 1. And our minimum value is going to be shifted down 2 units. So it was at negative 1 and now it's going to be at negative 3. So when I'm doing my scale on my y-axis, I need to make sure that I'm able to get to the number negative 3, and on the positive y-axis 2, which means it makes sense to make 2 squares 1, so 2, 3, and we've got negative 1, negative 2, negative 3. So try that scale and quickly graph sine x on your own. So now that I have a scale, I'm ready to add my points. So again, we're working with sine, so we know the sine of 0 is 0, so we're starting at 0. It's going to come back and hit 0 again at 360 because it's going to come up and down and back again. So we know it's going to hit 0 in the middle, which is going to be 180. It's going to hit its maximum value at 90, so its max value is 1. Make sure that you are not bringing it all the way up to 3 because it's not 3, it's 1. And then it's going to hit its minimum value, negative 1, at 270. And let's continue for our second cycle. Now that we have both cycles graphed, let's connect it. So we've got our first graph graphed, y equals sine x. So I'm going to label it, but I'm going to label it at the end because so that I can put all the labels in one place. So the next one I'm going to graph is the guy right beside. We're graphing sine x plus 1. We know that's just going to be shifted up 1. So we're going to take every single point on sine x and we're just going to shift it up 1. So remember, 1 unit is not 1 square. 1 unit we defined as 2 squares. So we're going to bring this dot up 1, which is 2 squares. Everything up 1. So it looks like this. Up 1, up 1, up 1, and the last guy right here. Now that we have that done, we can just connect them. Done. And again, I'm going to label it at the end so we can see all the labels together. And we're going to work on our last guy here, which is sine x minus 2. So we already know that that's going to be just the graph of sine x and shifted down 2 units. So remember, we're not shifting the blue guy, we're shifting the red guy because that's the graph of y equals sine x. So we're going to take every single red point and just bring it down 2. So as a reminder, 2 squares is not 2 units. We defined 2 squares as 1 unit, which means we're going to shift it down 4 squares. So we're going to shift the first guy down here, the next guy here, and then again 4 squares all the way down to there. And now that we have all of our points, we're ready to connect them. Now that we've graphed all 3 graphs, let's add our labels. Now let's start filling out some information about these graphs. So after we've shifted it, now we can take a look at what's the amplitude, period, domain, and range of these newly transformed graphs. So taking a look at sine x plus 1, which is the blue one, what's the amplitude? Have we stretched it at all? What is the distance from the middle of this graph to the top? Well, the middle of the graph is now at 1 because it was shifted up 1, and the distance from 1 to the top is still 1 unit. The amplitude has not changed, so our amplitude is still 1. In terms of our period, we haven't stretched it at all, so one cycle is still 360 degrees, so the period is still 360. Our domain is, well, x can be absolutely anything because this is going to be continuous forever. However, it did ask us to graph only 2 cycles of this. So let's do the domain of the 2 cycles that we were asked to graph. So we know that x has to be between 0 and 720. So far, nothing has changed. Our amplitude is still 1, our period is still 360, and for 2 cycles of the graph of sine x, it's going to be between 0 and 720. But what's going to change is our range. So looking at our red graph, we can see that the range used to be that x had or y had to be between 1 and -1. And now that we've shifted up, we can realize that y has to be between 2 and 0. So again, our range has to be between, y has to be between 0 and 2, and it can equal both 0 and 2. So in a similar way, taking a look at our green graph now, the one that was shifted down to, our amplitude is still 1. The distance between the middle of the graph, which is now at -2, and the top is still 1. Our period is still 360. Our domain also hasn't changed. If we're just talking about 2 cycles, it has to be between 0 and 720. And again, our range has changed. So now instead of y bouncing between 1 and -1, it's going to bounce between -1 and -3. So y has to be between these 2 values. So we can write that y is an element of all real numbers such that y has to stay between -3 and -1. So just as a reminder, when we have a vertical shift like what we've done, the only thing that's going to change is the range. Now let's start working with some horizontal shifts. So it asks us to graph 2 complete cycles of cos x, which is our parent graph, cos x plus 30, and cos of x minus 90. So we know here, because we have this plus 30 here, we know we're going to move to the left 30 degrees. And we know if we have x minus 90, we're going to move to the right 90 degrees. So let's start planning out what we're going to do for our scale. So can I copy the exact scale that we use on the first page? Well, on the first page, we just had to get all the way up to 720. But if we're going to move to the left 30, first of all, that means that our first value is not going to be 0, it's going to be -30, because we've got to bring that first point, which is going to be 0, 1, to the left 30. So first off, I know that I have to start my y-axis. Not here, maybe right here, so that I have room enough to put -30 here, because we're going to be shifting to the left 30. On top of that, I'm also shifting in another graph, moving to the right 90. So if I start writing a little note to myself that the minimum x value here, the x value has to be -30, and our max x value, well, max x, if we originally were supposed to go up to 720 because we've got 2 cycles, we've got to add another 90 to that to find our maximum x that we need to graph. So we need to be able to get to 810, which we came to by taking 720 and adding 90. So after just a quick calculation, I realized that I can get to both -30 and a maximum of 810 if we call each of these squares 30 degrees, which means that every 2 squares would be 60 degrees. So I'm going to quickly add my scale in now. So now that I've added my scale in, I can see that I will get to 810. I was able to get all the way to 900. And I will be able to get to negative 30 as well because I was able to get to negative 60. So now for our scale on our y-axis, because we're not shifting up or down, our maximum value will still be 1 and our minimum value will still be negative 1. So I can put the 1 wherever I want. I think I'm just going to stretch it as much as I can, just so that my points are as spread out as possible. So I'm going to count 6 squares as 1. And now we're ready to start adding our values. So let's start with cos x. So our scale is a little different, but our points will still be the same. So we know the cos of 0 is 1. So we're at 0, I'm going to put a big dot at 1. And I know that my cycle is going to end at 360, so it's going to come back to 1 at 360. And then I know it's going to hit its minimum value in the middle of 0 and 360. That's going to be 180. So 180 is going to hit negative 1. And in between 0 and 180, that's going to be 90. And 90 is right here. So graphically, it's right in the middle. And also just like numerically, 90 is between 0 and 180. So I can put a dot at 90 as well as another dot at 270. And now I'm ready to graph my second cycle, so try that on your own. And now that we have 2 cycles of our cos x, we're ready to connect them. So really the hard part's over. The hard part was coming up with our scale and planning it. Now it's just easy. Now we've got everything ready to start shifting this cos x to the left 30 degrees. So we've defined 30 degrees as one square. So I'm just going to underline this guy so we know which one we're working on. This one I'm going to work on in blue. So I'm going to take every single point and I'm going to shift it 1 square over because that's 30 degrees because we're going left 30 degrees. So I'm going to take our first point, bring it to the left, and here we go. So one by one we're going to move them over to the left, which represents 30 degrees, so 1 square. Now that we've done that, we can connect them. There it is. And I'm going to add in a label at the end once I've got everything done. So now let's do our last one. So we have cos of x minus 90, and so we know that that means we're going to move our original cos graph to the right 90 degrees. And again, we're moving this red one because that represents our cos graph. And 90 degrees we've defined as 3 squares. Sorry, 90 degrees we've defined as 3 squares. So we're going to take this red graph and we're going to move every single point over 3 squares because 1 square is 30, so 3 squares would be 90. So our first point will be here. That one's a little off. Let me make that better. There we go. 3 squares over. And now that we have all the points plotted, we can just connect them. And you should get something that looks like this. Now we can quickly add our labels. And now that we have all 3 graphs graphed, we can answer the quick questions below. So if we take a look at the amplitude of both of these, the amplitude for both the blue graph and the green graph is still 1. The distance from the middle to the top is 1. So we have our amplitude is still 1. Our period also hasn't changed. Our period is still 360 degrees. Our domain has changed slightly because we've shifted to the left and to the right. And so our domain of our graph of, or 2 cycles of the graph of cos should be between 0 and 720. But when we shifted to the left 30, our domain is now negative 30 to 690. And our domain for the green guy that was shifted to the right 60 is, sorry, it's been shifted to the right 90. Its domain is between 90 degrees and 810 degrees. In terms of our range, we have not shifted up or down, so our range is still the same. Both graphs, the blue graph and the green graph, are just bouncing between the numbers 1 and negative 1.